A perfect standing wave, soon to be shown in blue in this figure, forms on a string when two traveling waves, identical except that they're traveling in opposite directions, interfere. The amplitude of the standing wave equals twice the amplitude of either traveling wave. And all of the waves, standing and traveling, have the same wavelength lambda and frequency f. The equation for a standing wave is shown here. Y as a function of x and t equals the amplitude of the standing wave, sine kx times sine omega t, where the wavelength lambda is 2 pi over k, and the frequency f, 1 over the period, is omega over 2 pi. Part A asks us to find the spacing between adjacent nodes. Several nodes are shown here, and we can notice first that they are spaced half a wavelength. So this distance d is half a wavelength. We also know from properties of the sine wave that d equals the space between antinodes. Several antinodes are shown here. So we can find the distance d equal to the space between antinodes, given in the problem statement, 0.150 meters. Part B asks for several things related to the two constituent traveling waves. First, we can find their wavelength. That's twice 0.150 meters, or 0.300 meters. The amplitude of each traveling wave is half the amplitude of the standing wave, which works out to 0.425 centimeters. The frequency of each traveling wave is 1 over the period given in the problem statement. That works out to 13.3 hertz. And finally, their propagation speed, lambda times f, wavelength times frequency, works out to 4 meters per second. Part C asks for the minimum and maximum transverse speeds on an antinode. The transverse speed is v sub y, the magnitude of the y component of velocity. That's dy dt, which equals amplitude of the sine wave times omega sine kx cosine omega t. On an antinode, the sine kx term always has magnitude 1. So the minimum value of this velocity, which is 0, occurs where the cosine term equals 0, and the maximum value occurs where the cosine term equals 1. Substituting the values for the amplitude and omega gives us a maximum speed of 0.710 meters per second.